Hello class, this is a brief introduction to mean and periodic annual growth increments. So we talked about using other tools for understanding when to thin, when to harvest. So these are another set of tools to think about when to implement different silvicultural treatments. So a mean annual increment, or MAI, is the average yearly growth computed for volume, weight, or other measure up to the time of a measurement or projection. So the peak of MAI, this peak is referred to biological maturity. So we see this mean annual growth. And so mean annual growth is the total diameter growth divided by total age. So we see this mean annual growth kind of moving up. And we'll talk about this current annual growth in a second, but we see this kind of smooth line and we see this peak of where we have biological maturity, or we see the peak of individual tree growth, and that relating to overall stand projection. So we have tree age and we have DBH growth. So this is how it's generally calculated. We have our mean annual increment. We take a tree cookie, we take a tree core, and we look at the growth rings. So MAI, total diameter growth divided by total age. Total diameter for 5 years divided by 5 is the average growth for the first 5 years. Whereas our current annual growth, so this peaky line, is the increase in tree size for 1 year. When they cross, we harvest the stand. So we can see this from and thinking about what we understand about silvics and stand dynamics. We see this increasing growth. We see this huge increasing growth. So there's resources available. The trees are free to grow. They're free to grow. And all of a sudden, they're not free to grow. So there's competition occurring, or resources aren't freely available. And so the tree's not, so what this is saying is that the growth, it's still growing. We see the tree is still growing and it's still increasing in DBH. So it's not passing the zero line of no growth. It's just not growing as fast. That's the key. So it's not growing as fast. And this mean annual growth takes this kind of change into understanding. So every 5 years, we see on average it's going X amount. So it's averaging these first 5 years, it's averaging 5 to 10, it's averaging 10 to 15, etc. And putting this on a much smoother line. So the tree may have peaked, but we still see this general trend in increasing projection for the stand. And all of a sudden at this point we see that this is a diminishing returns on the stand level on the individual tree. It's not growing as much as it could, as much as the potential, and we see this general decreasing growth in how much is being accumulated, how much biomass is being accumulated. Again, remember, the trees are still growing, so they're still putting on growth. It's just not as fast. So I want to re-emphasize the point. Just because we see a downward slope doesn't mean the trees aren't growing. They are still above that zero line. They are still putting on DBH. So periodic annual increment, or PAI, is similar to current annual increment. It's the difference in tree size between the start and the end of a growth period divided by the number of years involved. So it's, again, not your total year. So every 5 years we might look at periodic growth. So here is our tree cookie, and we see that these rings, we can see both early wood and late wood, and we can use these rings to get an idea of the resources available for the tree. So in this example, this tree, when it was cut down, so we see something, a branch maybe is happening there, but we see this tree was not limited. So the rings haven't started to decrease. This tree still had plenty of available resources, plenty of growing space to take advantage of. That's compared to these tree cookies down here. So we see over here, we see the bark over here and the pith over here. So this is chopped off. But we see there's really great rings here. So really great growth here. And then all of a sudden, there's not as great growth. So we see a reduction in that growth. And this is an example where we're taking if we took the length here, that would give us our current annual increment. Whereas if we took the length of these first 5 years, so 1, 2, 3, 4, 5, divided by 5, that would give us our mean annual increment. So current annual increment, mean annual increment. And that is how we can get that information from that chart. So we see from this cookie, we haven't reached that reduction in growth. Here we are seeing that reduction, that especially as we get to these later years, there's just not as much basal area, there's not as much diameter being put on. So what does that look like when we actually graph it? So we can see the annual growth, and we go, there's probably years where it's going well, there's years where it's not putting as much growth on. And we see there's some really great growth going on. So there's growth, it's growing, it's putting on these great rings, and then it's not. So we see this potential dramatic fall off. And this kind of catches up with us in the mean annual increment. So in this case, it's every 5 years that we're getting an average. So on average, it's going that much. On average, it's going that. So we can see that. And sometimes it's not always the case. So this is an example from Lake Vandus, where we looked at the red pine, where I looked at the red pine, and we see that that is a case where we don't see that necessarily example of that kind of Avery and Burkhardt example. We see a different kind of trend in those growth rings. So that kind of sums up what MAI, PAI, CAI is. So for your assignment, it'll be posted on Moodle, but you're going to be using this example of a tree cookie here just because when we use the data from Lake Vandus, we don't get the greatest example. So we're going to use this example. I want you to kind of work through that. Again, it will be posted on Moodle. And this wraps up MAI, PAI, and CAI. Thanks.